We're going to model the projectile motion of a coin, which is dropped from the Burj Khalifa in Dubai. So it stands at 22 feet tall. So we want to begin here by writing an equation that's going to model this coin's height as a function of time, right? So if it's a function of time, that means time is the input variable, and then the coin's height is going to be the output variable. So we'll use h of t as the height in feet, and then t as the time in seconds. So with this projectile motion, we know we're going to have a t squared term and a t term, and then just a constant. So because this is in feet, and then we know that gravitational acceleration on Earth is 32 feet per second squared, we have to do negative half of that, so we need a negative 16 coefficient of t squared to get negative half of that 32. Because the coin is dropped, what that means is the coin is going to have an initial velocity, or its initial speed, of nothing. So at the moment it gets dropped, it's going to be traveling 0 fast. So since we do need this coefficient right here of t to be the initial velocity, it's actually just going to be 0, so plus 0t. And then what we need to add at the end right there needs to be the initial height of the object. So if it's going to be dropped from the very top of the Burj Khalifa, it's going to be at the height of the Burj Khalifa, which is 22 feet above the ground. So we're going to need 2,722 feet right there for the c value. So if you really simplify that equation down, right, because 0 times t is just going to be 0, this equation really is just negative 16 t squared plus 2722 is going to be equal to h of t, therefore. All right, so using this equation here, we're going to solve for a number of characteristics about the coin that is dropped here. So first of all, how high the coin is after 8.5 seconds. So if we were to do so, we would know that t is 8.5, right? So we could plug in 8.5 in for t. So just be taking negative 16 times 8.5 squared plus 2,722. Evaluating that. So yeah, if you do 8.5 squared, you get 72.25. That you then just have to times with negative 16 and add 2722 to. So that'd be negative 1156 plus your 2722. And that would give you a final answer then of 1,566 feet. So that's how high it would be still above the ground after 8.5 seconds. Pretty crazy, right? Even after 8.5 seconds, that it's still that high in the air. So it takes a long time for it to reach the ground there. All right, and then jumping over to this question right here, what the maximum height of the coin is. So the maximum height of the coin is going to be, what's the highest that it's at, right? So actually, if it gets dropped, you kind of should already know what the maximum height is going to be, because, yeah, it's just going to be at 22 feet, right? So that's one that you probably don't have to think about too much. But in terms of, like, if we were to actually try to find that from the equation, then since the equation we know is h of t equals negative 16 t squared, plus 2722, since it's really in standard form, where I'm going to maybe sneak in plus 0t plus 2722, we'd have to find the axis of symmetry, so when it's going to reach its maximum height. So the axis of symmetry would be at negative of b over 2 times a, which would just equal 0. But then you'd have to plug in that time of 0 into the equation and find h of 0, which would be negative 16 times 0 squared plus 2722. But that's just going to equal 2722, right? So, of course, that will just give you the maximum height there. Okay, and then if we jump to this here, when will the coin hit the ground? Well, that means that the height would be equal to 0, right? So just plug in a 0 in for the height. So 0 is going to be equal to negative 16 t squared plus 2722, and then you can solve that. If you want to use quadratic formula, you could, but if you realize that we just have a number and then the squared term, you could just use square root property. You just got to get the numbers all the other side, right? So if I subtract 2722 from both sides, this is equal negative 16t squared, and then I can write that as t squared equals negative 2722 divided by negative 16, if we did that to both sides. But since that's a negative divided by negative, we could write that as a positive, and then we can square root both sides of that to solve for t. So t is going to end up giving you both positive and negative. You're actually going to have a 4 in the bottom, because we know the square root of 16 is 4, and then the square root of 2722. So it'd be nice, of course, to kind of a decimal approximation for this. So it would actually be approximately plus or minus 13.04 seconds at which it would hit the ground. The negative time wouldn't make sense, right? Because it's not going to happen backwards in time. So really at 13.04 seconds approximately, right, is when it's going to be able to hit the ground. All right, and then finally, one last question here. How much time will pass during the coin's first 300 feet of falling? So we want to know the amount of time, right? So a t that's going to happen during the first 300 feet of falling. So when it's, during the first 300 feet. So what that means is we don't want the height to actually equal 300, right? Because that would be like it fell a whole bunch from 2722. It's during the first 300 feet. So if it's at 2722 to start with, and if it falls 300 feet, so subtract 300, it's going to be at a height of 2422 feet. So we'd actually need to plug in 2422 feet in for the height into the equation to find the amount of time at which it would be at that height, right? So what that does mean then is then we could solve this similar to what we did here just by using the square root property. So now if I subtract 2722 from both sides, we get a negative 300 on that side. And then if you divide by negative 16, you get 300 sixteenths is equal to t squared. And then you can square root both sides of that. So t is going to be equal to the square root of 300, but actually, if you know the square root of 300 is square root of 100 times square root of 3, and since the square root of 100 is 10, you could write that as 10 root 3, and you'll notice that we have the 4 there on the bottom, because we know the square root of 16 is 4. So yeah, you get that right there as kind of the exact solutions, and now that I zoom into that even a little bit more, and I think about 10 over 4, that can even be reduced. So even simplifying further, we can write that as 5 root 3 over 2. Then plus or minus of that, those would be the times. Now as a decimal, it's about 4.33. So at about 4.33 seconds, then that's when we would see it fall like this first 300 feet.